Welcome back, everyone. We're going to continue with the hypothalamus and the pituitary gland, and the detailed learning objectives are as follows. So be able to list the major hormones produced by the anterior pituitary gland, identify their targets and outline their effects. Then be able to explain using examples how the hypothalamus and target organs regulate hormone secretion by the posterior and anterior pituitary gland, and summarize the major effects then of growth hormone. So now let's have a look at the connection between the hypothalamus and the anterior pituitary gland. So hypothalamic neurons secrete releasing hormones and inhibiting hormones that either stimulate or inhibit hormone secretion by the anterior pituitary gland. Now remember that the posterior pituitary was a direct extension of the hypothalamus via the infundibulum. But the connection between the anterior pituitary gland and the hypothalamus is via a network of capillaries. Okay, so these hormones that are produced by these hypothalamic neurons travel through a network of capillaries called this hypophyseal portal system. So hypothalamic hormones, so we're looking here at this green ball here, which is representing a releasing hormone, then travel through a primary plexus of capillaries to the portal veins, which carry them into the anterior pituitary, which is what you just saw there. And then hormones shown here via this red ball produced by the anterior pituitary in response to the releasing hormones then enter the secondary capillary network and drain into the circulation. And then they're transported to their targets to have their effect. So we might just look at that again. We've got our releasing hormone here, and it enters that primary capillary plexus into the anterior pituitary gland. And in response to that releasing hormone, the anterior pituitary gland then makes another hormone which enters a second capillary network and drains into the circulation. And the beauty of this sort of network of capillaries, known as the hypophyseal portal system, means that the hormones that are produced in the hypothalamus don't get diluted out in the general circulation. All of them, gets directly transported into the anterior pituitary gland. So now looking at the hypothalamic hormones that regulate the anterior pituitary gland. All of these ones listed in green are releasing hormones, and the two in red are inhibiting hormones. We have the target and then the response to all of these hormones. Some of them have strange names, by the way. So thyrotropic releasing hormone, or abbreviated TRH, its target are specific anterior pituitary cells that secrete thyroid stimulating hormone. So the response to thyrotropic releasing hormone is an increase in thyroid stimulating hormone secretion. Now, wherever you see tropic, you know that it's going to stimulate another endocrine gland, okay? And that's what we've just spoken about. Similarly, corticotropin releasing hormone, or CRH, targets specific anterior pituitary cells that secrete another hormone called adrenocorticotropic hormone. And in response to CRH, you're going to get an increase in adrenocorticotropic hormone secretion. It also has a tropic in its name because it's going to stimulate the adrenal gland, and we'll have more on that later. We have gonadotropin releasing hormone, or GnRH, and it targets specific anterior pituitary cells that secrete luteinizing hormone and follicle stimulating hormone. So again, that response to that releasing hormone is an increase in luteinizing hormone and follicle stimulating hormone. Much more on that when we get to the reproductive system. We have growth hormone releasing hormone, and it's a hormone that stimulates anterior pituitary cells that secrete growth hormone. So again, the response to that releasing hormone is an increase in growth hormone secretion. Similarly, prolactin releasing hormone, or PRH, targets specific anterior pituitary cells that secrete prolactin to increase prolactin secretion. Now with the red ones, you're going to get the opposite. So growth hormone inhibiting hormone, GHIH, also known as somatostatin, targets those similar anterior pituitary cells that secrete hormone, a growth hormone, but here the response is a decrease in growth hormone secretion. And similarly, prolactin inhibiting hormone stimulates those acts on those anterior pituitary cells that secrete prolactin to cause a decrease in prolactin secretion. So now moving on to the 6 hormones of the anterior pituitary gland. And we're just going to look at their major effect here. So growth hormone is the first one. It has many targets, including the liver, muscle, fat, cartilage, and bone. And its major effect, as its name suggests, is to promote widespread tissue growth, right? We have thyroid stimulating hormone, and its target is the thyroid gland. So it will stimulate the thyroid gland to secrete thyroid hormones, but it also is involved in promoting thyroid growth as well. That adrenocorticotropic hormone, which is abbreviated to ACTH, its target is the adrenal gland, the outer region of the adrenal gland, and it will stimulate the secretion of the glucocorticoids. So when we're thinking about glucocorticoids, we're mainly talking about cortisol. And it will also promote growth of the adrenal cortex as well. We have follicle stimulating hormone. Its target is the ovaries and the testes, and it will stimulate growth of ovarian follicles and estrogen secretion in females and promote sperm production in males. We also have luteinizing hormone, and its target is also the ovaries and the testes, where it stimulates ovulation and maintenance of the corpus luteum in females and promotes testosterone secretion in males. Now, if you're not sure what I'm really talking about here, I'm purposely just, skimming over these reproductive hormones because, again, we'll talk about them much later on in the subject. And prolactin, then, its target are the mammary glands and also the testes. And it will promote milk production in females and luteinizing hormone sensitivity in males. So just looking at a summary then of the regulation of anterior pituitary hormone secretion. So the hypothalamus secretes those releasing hormones or inhibiting hormones into the hypophyseal portal system, where they travel to the anterior pituitary gland, and in response to the releasing hormones, the anterior pituitary cells release other hormones that then enter the blood, and they then travel to their target cells. So regulation then by negative feedback ensures that the hypothalamus can alter the secretions of the anterior pituitary, which in turn then can alter target gland hormone secretions and therefore the responses of their target tissues. And that's what we're looking at here in terms of the negative feedback loop for blood hormone level regulation. So from the hypothalamus, those releasing hormones stimulating pituitary hormone to be released from those anterior pituitary cells. And very often then that pituitary hormone, its target is another gland, which then releases another, peripheral hormone, which then has, cellular effect. So targets particular cells and tissues. Now, as the levels of those peripheral hormones build up in the blood, then you can see very clearly from these little red minus signs that they feed back on the hypothalamus to switch off the production of that releasing hormone and the anterior pituitary hormone as well. Okay, so let's start putting some of this all together and showing you the connection between the releasing hormone and then the anterior pituitary hormone and then the target gland and what's happening there. So I'm going to give you the example of thyroid hormones for this first one. So the thyroid gland itself is regulated by thyroid stimulating hormone, as you know. And thyroid stimulating hormone is released from the anterior pituitary in response to that thyrotropin releasing hormone from the hypothalamus. Thyroid stimulating hormone triggers the secretion of thyroid hormones via the thyroid gland, and they then enter the bloodstream, and they travel to their target tissues, and one of their effects is to increase metabolic rate. And then elevated levels of thyroid hormones in the bloodstream then trigger a drop in the TRH and also the TSH. And in that way, we get maintenance of normal levels of thyroid hormones in the bloodstream. So when we get to the tutorial, we'll talk a little bit more about the thyroid hormones and what happens if you have too much of them or too little. Another example here is the regulation of the levels of glucocorticoids or cortisol in the bloodstream. So adrenocorticotropic hormone stimulates the adrenal cortex to secrete glucocorticoid hormones such as cortisol. And the release of ACTH is regulated by corticotropin releasing hormone or CRH from the hypothalamus in response to normal physiological rhythms. And then, elevated, firstly, when cortisol is secreted from the adrenal gland, it will, act on nearly all tissues and cells in the body. It has sort of diverse effects. It's the major stress hormone in the body. It has metabolic effects. It will cause a suppression of the immune system at high levels and also has an anti-inflammatory effect. But for the purpose here, once cortisol levels start to build up in the bloodstream, that then triggers a decrease in the production and secretion of CRH and subsequently then ACTH by the anterior pituitary. And again, the whole net effect of this is to keep cortisol levels in the blood at normal, sort of within homeostatic range. Now, if all of this is just getting too much for you and you can't, pronounce some of these really long, complicated words, and if you are a Star Wars fan, I want you to sort of think about it in this way. We have our hypothalamus, right? The hypothalamus is controlling the anterior pituitary. This is a little bit like Yoda, right? So Yoda is that really wise character from Star Wars, full of wisdom, advises then Obi-Wan Kenobi, right? So I want you to think of Obi-Wan Kenobi as the anterior pituitary gland. Now, he's quite powerful too himself, and he advises other target glands such as the adrenal gland, and in our case of Star Wars here, we're talking about Luke Skywalker. And then Luke Skywalker then is, cortisol in this case, and it's then having its effect around the body. So remember it, hypothalamus is Yoda, anterior pituitary is Obi-Wan Kenobi, and the adrenal gland, or it might be another gland, say such as the thyroid gland, is Luke Skywalker. I know it's ridiculous, I know, but sometimes we just need to think of other, ways of remembering or understanding stuff. And I just happen to be a Star Wars fan. We have all of these reproductive hormones as well being regulated by gonadotropin releasing hormone, luteinizing hormone, and follicle stimulating hormone. This slide is just summarizing for the female, and the next slide for males. So I'm going to leave that alone. I think it's a lot of information to take in when we will be talking about it later on in the subject. The final hormone we're going to talk about in this part of the topic is growth hormone. So the endocrine system does regulate growth, protein synthesis, and replication of cells. And growth hormone, which is also known as somatotropin, is the major hormone that's involved. Growth hormone levels are controlled by the release of growth hormone releasing hormone from the hypothalamus, and also controlled by growth hormone inhibiting hormone release as well from the hypothalamus. And growth hormone inhibiting hormone is also known as somatostatin. Now, there's several different things or factors that, can stimulate growth hormone secretion. One of them is low blood glucose levels. Another one is stress, and another one is heavy exercise. And finally, high amino acid levels in the blood will also stimulate growth hormone secretion. And growth hormone secretion then is inhibited by several things as well, including high blood glucose levels, high levels of cortisol, and also obesity. So let's have a look at it in this diagram here. When growth hormone releasing hormone stimulates the anterior pituitary cells, growth hormone will be released. And it has, few different effects. It has a glucose sparing effect. What does that mean? It stimulates adipose cells to break down stored fat, fueling the growth effects, right? It also has growth effects itself. So it increases uptake of amino acids from the blood, and it enhances cellular proliferation. So it enhances, cellular division and reduces apoptosis, which is that programmed cell death. It also has what we call a diabetogenic effect, where growth hormone stimulates the liver to break down glycogen into glucose as well, and that will add, more glucose into the bloodstream and fuels growth effects. And it also causes the liver to release this insulin-like growth factor, and that will then further stimulate growth effects. Okay, so you can see the target tissues there, the liver, adipose, bone cells, muscle cells, nervous system, and also immune system cells. So the primary function of growth hormone is anabolic, and it promotes protein synthesis and tissue building through these direct and indirect mechanisms. The direct mechanisms, also known as the anti-insulin effect. So a glucose sparing effect occurs when growth hormone stimulates the breakdown of fat, and this is known as lipolysis. And many tissues will switch from glucose to fatty acids as their main energy source, and therefore less glucose is taken up from the bloodstream. Growth hormone also stimulates the liver to break down glycogen to glucose, which then enters the blood as well. We also have these indirect effects. So growth hormone mediates growth and protein synthesis by stimulating the liver to produce insulin-like growth factors, so those IGFs. These proteins stimulate cells to increase their uptake of amino acids from the blood for protein synthesis. Skeletal muscle and cartilage cells are particularly sensitive to stimulation from these insulin-like growth factors. So that's just summarizing those kind of direct and indirect effects of growth hormone. Now, remember on the previous slide, I did mention that one of the, stimuli for growth hormone secretion is heavy exercise. So you might go, into the gym a bit like this person here, and, really hit the weights really hard over long periods of time and stimulate your growth hormone secretion. And after a bit of time, my goodness, look what came out. A total transformation. I'm not sure growth hormone can make your manufacture helmets and shields, but I think you get the point I'm trying to make here. Okay, everybody, that does bring me to the end of this part of the topic. Again, before you move on to the next section, use the following summary slides to help you, consolidate what we've been talking about.